Hey guys, welcome to question MM313 of the Maths Methods Fortify study guide. So in this question we've got a function f of x equals 2e to the power of x take 2 minus 3. And we need to find, and we've got this graph here as well, we need to find the rule for f of negative 1, f negative 1, the inverse function of f. Awesome. So first things first, we need to make sure we show all working for this question. So what I would do is say for inverse, swap x and y, solve for y. I would write this for every single inverse question ever, just to make it super clear on what you're doing. So therefore x is equal to 2e to the y take 2 minus 3. Okay, so what we're doing is just swapping x and y, and then we're going to try and get y by itself. So then from here, we can say that x plus 3, so we're adding that to that side, then we're going to divide both sides by 2. So x plus 3 over 2 equals e to the power of y take 2. Now, to get y take 2 by itself, we're going to log this. So we're going to get log e of x plus 3 over 2 equals y take 2, right? So remember that log base this of this equals the power. Okay, so that's how we've kind of gotten to that point there. That's our fundamental log law. If you're not too sure about that, you really need to go back and revise that because that's really important. And then to get y by itself, we simply add 2 to both sides. So we get log e of x plus 3 over 2 plus 2. Awesome. Now, our first mark comes between here. So this step here is our first mark. Then our second mark is obviously our final answer here. Actually, no, it's not, okay? Because we haven't actually answered that fully. So, therefore, our inverse of f is equal to log e of x plus 3 over 2 plus 2. That's our second mark, okay? So we need to make sure that we actually answer, yes, this is our inverse, and not just leave it as y, because it's asking for the rule for f of negative 1, the inverse function of f. So that's it for part AI. Let's move on to part AII. So part AII is simply a 1-mark question, and I'm going to leave that there just for now. So part AII says find the domain of the graph of the inverse of f. Okay, so there's two ways to do this. We could use this inverse function and actually find the domain using this, or we could simply find the range of the original and say that that's the domain of our inverse. Okay. So because we're swapping x and y, the domain of our inverse is equal to the range of f, just our normal f, this bit here. So our range of f is what? It's negative 3 to infinity, right? It just goes up and up and up forever. But it never touches negative 3. So that means that our domain of our inverse is negative 3 to infinity. Okay, because our range of f is negative 3 to infinity, not including negative 3, which means that's a domain of our inverse. That's our first and final mark. That's our final answer for this question. If you have any questions, let me know. Let's move on to part B. Part B is a 3-mark question, and it's a sketching question. So we do have our CAS for this question, so you can use that to aid in your sketching. We should kind of be able to do this without a calculator by now. So it's a 3-mark question. It says, on the axes above, sketch the graph of y equals inverse of f and label all axis intercepts and asymptotes with their exact values. Awesome. So our inverse function was log e of x plus 3 over 2 plus 2. We're going to need to sketch this. So first of all, we know that our domain for this, according to our previous part, is negative 3 to infinity, right? Which means we're going to have an asymptote at negative 3, at x equals negative 3. So what we're going to do is we're going to say that we have an asymptote at here, x equals negative 3. X equals negative 3. Sweet. And it's a log graph, right? It's a positive log graph. So it's going to come up something like this. And we need to label these axis intercepts as well. So we've labeled our asymptote, that's all good, but now we're going to need to label our intercepts. How do we find intercepts? Using our x equals 0 and y equals 0, okay? So let's start with our y-intercept. So our y-intercept is where x equals 0. So we have log e of 0 plus 3 over 2, which is just 3 over 2, plus 2. Now, this is in exact value, and the question told us to label the intercepts with exact values. So this is exactly what we're going to label it as. So this is our our y-intercept. So this is equal to 0 log e of 3 on 2 plus 2. Sweet. Now we're going to find our x-intercept. So our x-intercept occurs when y equals 0. So we get log e of x plus 3 on 2 plus 2. Minus 2 from both sides, we get negative 2 equals log e of x plus 3 on 2. Now, according to our fundamental log law, e to the power of negative 2 is equal to whatever's inside here. So e to the power of negative 2 equals x plus 3 on 2. The reason we're doing this is to get x by itself, remember? So that's the whole reason why we're doing this. Multiplying both sides by 2, we get 2e to the negative 2 equals x plus 3. Therefore x equals 2e to the negative 2, take away 3. So this point here, where am I going to write this? Is 2e to the negative 2 minus 3, 0. Awesome. And it's okay to do this sort of thing. Like if you don't have much room, you can just use these like little arrow things, and that's perfectly fine. They'll know what you're talking about. So that's it. So as always with graphs, guys, it is a 3-mark question. They kind of give you 3 marks to begin with and then take marks off based on what you don't include. But we've included everything here, right? We've included the asymptote and its label. We've included the graph, positive log graph, and we've also included the intercepts in exact form. So that's it. So guys, that's part B done. Let's move on to part C. Part C is a 2-mark question. And what we're going to need to do is find the coordinates of the points of intersection between the graphs of y equals f of x and y equals inverse of f, okay? Correct to 2 decimal places. Awesome. So, for points of intersection, let f of x equal inverse of f of x. So therefore, because whenever we have points of intersection, we let them equal each other. So 2e to the x take 2 minus 3 is equal to log e of x plus 3 over 2 plus 2. Now, we cannot do this by hand, but we do have our CAS available. So, solve in CAS. This will be my line of working as well. X equals negative 2.99 and x equals 3.12. Awesome. That's our first mark. So our first mark comes when we find our x values. Now, because these are the points of intersection between our original and our inverse, these points here are going to go through our y equals x line. Okay, so our line that goes up like this. That's actually a really good sketch. Which means that our x value and our y value at these 2 points are going to be identical, okay? Because they must cross this y equals x axis. So x equals y. Therefore, our points of intersection are negative 2.99, negative 2.99, and 3.12, 3.12. That's our second mark. So guys, that's it for this part, C. I think this is a really good takeaway for this question, is recognizing that whenever you have the point of intersection between your original and your inverse, the x and y values are always going to be the same, okay? Because they're crossing that y equals x axis. Awesome. So let's move on to part D now. Part D tells us to calculate the area bound by the curve y equals f of x and its inverse, correct to 2 decimal places. So we're actually looking for this area in here. Awesome. So as always, guys, the area between 2 graphs is equal to the first point of intersection to the second of the top minus the bottom, right? So just for argument's sake, g of x take f of x dx. So our first point of intersection, as we found in the previous part, is negative 2.99. Okay, so negative 2.99 to 3.12. Our top graph is our inverse. So inverse of f of x minus our bottom graph, which is f of x dx. Okay, so that means that our area is going to be negative 2.99 to 3.12. Our inverse is log e of x plus 3 over 2 plus 2 minus 2e to the x take 2 minus 3 dx. That's our first mark. Okay, so this is a 2-mark question. That's our first mark. Now, it's a little iffy on how much, this is D, it's a little iffy on how much working you have to show here. I would just show as much as you possibly can with the space and the time that you've got. But after you've shown your working, what you'll actually end up with is your area is equal to 25.22 units squared. Now, keep in mind the question asked for corrected 2 decimal places. That's what we've done here. And because we're talking about area, we need to include our units squared. So that's what we've done here as well. That's our second mark and final answer for question, or part D in 313. Guys, that's it for this question. Please hit me up if you have any questions in the comments below. But otherwise, thank you so much for watching, and I'll see you in the next video.